In this video, you will learn how to add and subtract fractions in the context of algebra. Now, to understand how to add and subtract with algebra, you also need to know how to add and subtract with regular numbers. So let's do a quick review of how to add and subtract with fractions. So the addition rule for fractions says if we have a over c plus b over c, then I take the numerators and add them to get a plus b over c. So for example, if you had 4 over 11 plus 5 over 11, they both have the same denominator. I can add the 4 plus 5 to get 9, and that will be over 11. With subtraction, same thing. If we have a over c minus b over c, I subtract the numerators, a minus b, and put that over c. So example 2, here we have subtraction, 4 over 11 minus 5 over 11. So here we have the same denominator, so we can subtract the 4 minus 5 and put that over 11, which would give me negative 1 over 11. And the negative, by the way, can go on the top or on the bottom or just next to the number. All of those would be the same. So now that we remember how to add and subtract fractions with just regular numbers, now let's work with variables. So here we're going to have variables in the numerator, and we're going to have the same denominator. So example 3, we have 2b over 18 plus 7b over 18. Well, here this one is pretty quick because the denominator is already the same, so that means I just add the numerators, 2b plus 7b, which gives me 9b. So I have 9b over 18, and I can divide 9 and 18 both by 9 to get 1b over 2. Here is another example with subtraction. We have 6x minus 3 over 8 minus 3x minus 5 over 8. So here, this one already has the same denominator, so I can just subtract the numerators. So I take 6x minus 3 and then subtract 3x minus 5. Now be careful, because we're subtracting the entire quantity of 3x minus 5. So we're subtracting 3x, but we're also subtracting the negative 5. Alright, so when I subtract these, we have 6x minus 3, then minus 3x, minus a negative 5, which becomes a plus 5. And then simplify the top, 6x minus 3x would be 3x, negative 3 plus 5 is 2, so we have 3x plus 2 over 8. So this is when the variables are in the numerator. Next, we're going to show you how to work with variables in the denominator. So example 5, we have 2 over x minus 3 plus 3 over x minus 3. Now here, the denominators are already the same. So because of that, I keep the denominator and then add the numerators. So I have 2 plus 3 on the top over x minus 3 on the bottom, which would give me 5 over x minus 3. Another example, we have 3 over x minus 2 plus 7 over 2 minus x. Okay, this one is a little bit different because our denominators are not quite the same. But notice that the denominators are just opposites of each other. Here we have x minus 2, here we have 2 minus x. So what I can do, I can make them the same, and I do that by pulling a negative out of this expression. So I pull a negative out. So look over here, we have 2 minus x. If I pull a negative out, what happens is it changes the sign of everything on the inside. So this becomes a negative 2 and a positive x. So what I have is a negative, and then we have positive x, and then a negative 2. And notice this would be the same thing, because if I distribute back through, we'd have negative x and positive 2, which is what I had to begin with. I had a negative x and a positive 2. So I can rewrite that second fraction as negative, and then x minus 2. So if I'm adding something that's negative, which this would be negative, right? Positive divided by negative would be a negative number. This whole thing is negative. So if I add a negative, that is the same thing as subtraction. So I can think of this as a subtraction problem. So I have 3 over x minus 2 minus, and then 7 over x minus 2. So now the denominators are the same. I can now subtract the numerators. 3 minus 7, which would give me negative 4, and that is all over x minus 2. So that would be my solution. Now, what if your denominators are different? So here we see x plus 4 over 5 minus 2x plus 1 over 10. So here we notice that the denominators are not the same. So I need to begin by finding the least common denominator. So looking at 5 and 10, the least common denominator would be 10. Alright, so I need to convert both fractions so that we have a denominator of 10. The second fraction is okay already, but the first fraction, x plus 4 over 5, I need to write as something over 10. So to do that, we see what do we multiply the bottom by. So 5 times 2 would give me 10, so I multiply the top by 2 as well to get 2 times x plus 4. So my numerator of the first fraction would be 2 times x plus 4. Now here I would like to distribute the 2 because eventually I'm going to be combining with the other fraction. So we have 2 times x plus 2 times 4, which gives me 2x plus 8. So now from here, when we subtract, we can subtract the numerators. So we have 2x plus 8, and then minus 2x plus 1. And take note that we are subtracting the entire quantity of 2x plus 1. We're subtracting the entire numerator. So what that means is we're subtracting 2x and we're subtracting the 1. So we have a minus 2x and a minus 1. Now from here I can combine like terms. The 2x minus 2x would actually cancel. That would give me 0. And then 8 minus 1 is 7. So my answer would be 7 over 10. Now what if we had different denominators and we also had variables in those denominators? So here in example 8, we have a problem like that. We have 1 over 4a to the third minus 2 over 3ab plus 3 over 8b squared. So we need to begin by finding the least common denominator. So looking at the 4, 3, and 8, the smallest denominator, or I guess the least common multiple of 4, 3, and 8 would be 24. Okay, and if you forget how to do this, maybe refer back to a previous video where we explain how to find that least common denominator. Now looking at the a's, we have 3 a's here, which is the most that we see. So we take all 3 of those a's. And then the b's, we see 2 b's here, and that has the most of them, so we take 2 b's. And that would be it for the least common denominator. So from here I need to convert each of these fractions into a fraction with this new denominator. So looking here at our 3 different fractions, the first one we need to write as something over 24a to the third b squared. So initially we had a 4, now we have 24. We had to multiply 4 by 6 to get 24, so I multiply the 1 by a 6 as well. And then a cubed is what we started with. We still have a cubed over here, so the a's are good. We need b squared as well. We did not have b squared to begin with. Now we do have b squared, so I have to multiply the top by a b squared as well. So multiply the 1 by a 6 and a b squared. The second fraction, I have 24a cubed b squared as your denominator here, and I'm going to have to multiply the top by something to make this correct. So multiply the 2 by something. So what I multiply by is found by seeing what I multiplied the denominator by. So I had to multiply 3 by 8 to get to 24. So multiply the top by 8 as well. The a I had to multiply by an a squared to get to a to the third power. And then the b I had to multiply by a b to get to b squared. Alright, so my second fraction will look like this. And then the third fraction, we have my denominator as 24a cubed b squared as well. And then we take the 3 that was there at the beginning and multiply by something. So that something is found by seeing what I'm multiplying the denominators by. So 8 times 3 is 24, so multiply the top by 3 as well. And then we need a to the third power because that has changed in the denominator. And then we had a b squared, we end with a b squared, so the b's are okay. Alright, so we have these three fractions, which you will see typed down here, which might be a little easier to read. Alright, so from here I can combine. So I'm subtracting the 2 times 8a squared b. So we see that here. We subtract 2 times 8a squared b plus the 3 times 3a to the third power. So we can simplify this. We have this negative 2 times 8 would be negative 16. So we have negative 16a squared b. And then 3 times 3 gives me 9. So we have 9a to the third power. And nothing can combine in the numerator. So this here would be my final answer. So now we've worked with variables in the denominator, where the denominators are different. Now, what if we had polynomials in the denominator? So here we see x over x squared minus 1 minus 4 over x minus 1. So first thing is I need to determine a least common denominator, and to do that I need to factor any denominator that needs to be factored. So x squared minus 1, that is a difference of squares and can factor to be x minus 1 times x plus 1. So from here I need to determine what is my least common denominator. So to do that, I see what factors we have represented. So we have x minus 1s and we have x plus 1s. And the question is, how many of each do we take? Well, we take the ones with the most. So here is a tie with x minus 1s with just one of them. So we take just one x minus 1. And x plus 1s, this one has the most with 1. So we take just that one x plus 1. So my least common denominator would be x minus 1 times x plus 1. Now from here I need to convert the fractions so that they have that least common denominator. So this first fraction already has that least common denominator. So the first fraction is okay. The second fraction, however, needs to change to this new denominator. So that 4 over x minus 1, I convert to something over x minus 1 times x plus 1. So to convert, we notice that we're multiplying the x minus 1 in the original fraction with an x plus 1. That is what's changing from this fraction to the new fraction. So therefore I multiply the top by the x plus 1 as well. So that second fraction I'll write as 4 times x plus 1 over x minus 1 times x plus 1. Alright, so from here I can combine because they have the same denominator. So to combine, I subtract the x minus 4 times x plus 1, which is what we see up here. We just combine by subtracting the two numerators. And now we want to simplify the numerator a little bit. We can distribute the negative 4 with the x. So we have negative 4x, and then negative 4 times 1 is negative 4. So negative 4x minus 4. And then x minus 4x can combine. That would give me a negative 3x. So I have negative 3x minus 4 over x minus 1 times x plus 1. Now let's look at one more example where we have polynomials in the denominator. This one is a little bit more difficult, and here we see 3 over x squared plus x minus 6 minus 4 over x squared minus 3x plus 2. So to simplify, or I guess to combine these, I need to factor both denominators. So we're assuming that you know how to factor at this point, and if not, you can refer back to previous videos on how to factor. But here we see x squared plus x minus 6. That would factor to give me x plus 3 times x minus 2. This other fraction, the denominator can factor to give me x minus 2 times x minus 1. So we need to now find the least common denominator. So we look at each of the factors that we have represented. We have x plus 3. We have x minus 2. And we have x minus 1. And the question is, how many of each do we take? Well, we see which one has the most of each of these. We see x plus 3 only one time, so we take 1 x plus 3. X minus 2, the most we see it is one time, so we take 1 x minus 2. And we only see x minus 1 one time as well, so we take 1 x minus 1. So your least common denominator would be x plus 3 times x minus 2 times x minus 1. Now from here we need to convert these fractions into fractions with this new common denominator. So to do that, let's look at the first fraction. We're going to have this new denominator, and we need to see what is changing from the original fraction to the new fraction. So we started with x plus 3 times x minus 2. Now we also have an x minus 1 with that, so I need to multiply the top by an x minus 1 as well. And then the second fraction, we again need that denominator of x plus 3 times x minus 2 times x minus 1. So what's changing from the original fraction to the new fraction is we now have an x plus 3, and we did not originally. So I multiply the top by an x plus 3 as well. So we see that typed up right down here, what I just written up at the top. And from here we can combine the fractions by subtracting the numerators. So we have 3 times x minus 1 minus 4 times x plus 3. Now we could simplify the numerator by distributing. We have 3 times x and 3 times negative 1. That would give me 3x minus 3. And then negative 4 times x is negative 4x, and negative 4 times 3 is negative 12. So my numerator will be like that. We see it typed up here at the top. And then we can combine even further. 3x minus 4x, that would give me negative 1x. And then negative 3 minus 12 would give me negative 15. So my numerator is going to be negative x minus 15. And this would be my solution after I subtract and after I simplify the numerators. And that concludes our lesson for today. We will see you next time.